Hello everybody, I am Krishna Rao Patro, Assistant Professor in the Department of Computer Science and Engineering from Institute of Aeronautical Engineering College, Hyderabad. So today we'll discuss about one important concept in Java, that is typecasting. The typecasting is the one which talks about how you can convert from one data type to another data type. So for every programming language, this is the one common requirement. How will you convert from one type to another type while solving the problem? Changing a value from one data type to another data type is known as data conversion. This is also known as typecasting. There are two types of typecasting again. One is implicit typecasting, second one is explicit typecasting. Implicit typecasting means automatically which will be converting from one type to another type. Explicit typecasting means you have to convert explicitly, that means manually. So implicitly typecasting is also called automatic typecasting. Similarly, explicit typecasting is also known as manual typecasting. So in a simple form you can say. Or this implicit typecasting is called widening typecasting. Okay. Similarly, explicit typecasting also known as narrow typecasting. So these are the two important types of typecasting. So with the help of the typecasting, you can convert one data type to another data type. That means the value of the variable you can convert from one type to another type. First we will see what is implicit typecasting. Implicit typecasting is the one which will be done automatically by the system itself depending upon their type of data. Whenever conversion automatically performs by the compiler without programmer's interference is called implicit typecasting or widening typecasting. That means the programmer need not write explicit syntax while converting from lower data type to higher data type. In implicit typecasting, conversion involves smaller data type to larger type. So that means lower category data to higher category data you can convert automatically. For example, byte data type, implicitly you can convert into short, char, int, long, float or double. Actually byte is a shorter one, simpler one, very smaller one, which you can convert to higher type. Similarly, short you can convert it to character, integer, float, double. Similarly, integer you can convert into long, float, double. So from lower to higher you can do automatically. So in the diagram it is given byte first, smaller one, next short. Actually byte requires 1 byte, short requires 2 bytes, int requires 4 bytes, long requires 4 bytes. Sorry, long requires 8 bytes, float requires 4 bytes, double requires 8 bytes. So in this order you can convert from one type to another type. So this typecasting also known as what? Widening. A simple example of implicit typecasting. How you can write a program. That means here you need not write explicit syntax to convert from one type to another type, because this is implicit or you can say automatic. Okay. For example, here I have declared a variable called b, of what type? Byte type. Now value of b is how much? 12. This value I want to store in integer variable. Actually byte is smaller one, integer is bigger one. So now when I am assigning the byte variable into integer variable, automatically it will convert it. Byte is converting to integer type. So this type of sentence is known as what? Implicit conversion or implicit typecasting. And when I am printing the value of r, it will print how much? The 12 only. So this program will print how much? 12 here. Next, I am writing one more sentence. If you observe here, long sc equal to r. Sc is what type? Long variable. Whereas r is what type? Integer type. So r requires 4 bytes, whereas sc requires 8 bytes. So this 4 byte data you can convert into 8 byte data automatically. So this type or this sentence is called what? Implicit typecasting statement. Implicit typecasting statement. It will convert integer to long automatically. You need not write explicitly. Similarly here, float t equal to s. That means what? S is my long type, whereas t is float type. Now when you assign, automatically that will convert into float. Okay. So now print the value of t. So it will print the t value. So this is a simple example of a implicit typecasting. So remember, the lower data type can be converted into higher data type automatically. This type of typecasting is called implicit typecasting, or also called automatic typecasting, or also called widening typecasting. Widening. Okay. Next, we will go for another typecasting, that is explicit typecasting. This explicit typecasting is also known as narrowing typecasting. What do you call? Narrowing typecasting. That means you are converting the data from higher to lower. Higher to lower. The process of conversion from higher data to lower data is known as narrowing typecasting, or also called explicit typecasting. That means you forcefully converting. Forceful conversion from one type to another type. This is also known as explicit typecasting. It must be done explicitly. That means explicitly the programmer has to write, you want to convert from this type to another type. You can see the order of the explicit typecasting also. Double, float, long, int, short, byte. See the arrow mark. That means you are converting double to float. It requires explicit typecasting. It is not comes under implicit typecasting, because double is 8 bytes whereas float is 4 bytes. When you are converting from higher to lower, you have to go for explicit typecasting only. So this is the order of the explicit typecasting. A simple example how you can do explicit typecasting. Now here I am having one variable called I, what type? Integer type, and one variable called B, byte type, and one variable called D, double type. So there are three variables are there: byte variable, integer variable, and double variable. Now I am converting this integer variable to byte. Integer variable to byte. Actually, byte requires 1 byte of memory, whereas integer requires 4 bytes. Now you are converting integer to byte. That means 4 byte data you are storing in 1 byte. So there is a chance of data loss also. So while doing explicit typecasting, there is a chance of data loss, because you are converting from higher to lower. So for explicit typecasting, you should write within parentheses the data type to which type you are converting. So first variable name equal to, then within the parentheses you should write the syntax to which type you want to convert. Assume I want to convert into byte type, then write byte. And which variable? Assume the I is my integer variable. This integer variable data I want to convert into byte. So that must be written within the parentheses. That is the syntax. So you have to follow this one. So this is a forceful conversion from integer type to byte. Okay. So this is explicit type conversion. Next statement. B equal to byte of D. B equal to byte of D. D is what? My double variable. This double variable data I am storing in B. Automatically, the double data also convert into byte type. So here, the double data, my D is the variable and byte is my required conversion. Then B is my variable where the data has to be stored. So it is converting the double data to byte data. And finally, I am printing the value. So this is the way you can write the program while converting from explicit typecasting to normal variable to explicit typecasting. We'll see a small program how to execute this program. I'll show you a small program to execute it. D drive, CD. I made a folder called Patro. Here, I'll write. Assume I am having one program called hello.java. This program, better I will open my Notepad++. Notepad++. It is easy for you to know how to write the program. Okay. I think you are able to see now this program. This program, I'll write main. Main is my class name. Here, I'll write public. For every Java program, you must write the first main method. The main method syntax is public, because it must be accessible by everybody, everywhere. Public, static, and it must be called directly by the compiler without creating object. That's why it is static. Void, and this method returns nothing. Void. Then the name of the method is main, and this method takes the special argument, that is string argument array. So this is the general syntax of my main method in Java. Now I am writing a variable called byte b and integer I equal to, for example, 258. Now I am storing b in I. Then I am printing that value. System dot out dot println followed by I value. I'll print I equal to how much? This value plus I. At the same time, I want to print my b also. If you observe here how the compiler reacts, you see what type of error we are getting. First of all, you should know the error. Once the error comes, then how to rectify it. Now, here b is my byte variable, I is my integer variable. Here I am storing I in b. That means I is integer variable, b is byte variable. So that means what? You are storing higher data to higher data stored in lower data. Higher data variable stored in lower data variable. Okay. Now, what type of error we are getting? You see, Control S. I have saved the program. What should be the name of the program? Because my name of the class is main, so I will convert that program to be also main. Because generally the better practice is class name and file name better to be same. So I will rename to as a main, and it should be what type? It should be Java type. Select Java source code file, save it. So automatically my program name is main.java. Now I have to compile it. For compiling, I have to go to my command prompt, right click, open into the command folder, wherever the file is there, it will go there. Yeah, I got to, means I have gone to my folder. It is available in the D drive Patro folder. Now I have to compile it, Java C followed by main.java. Once I compile, then you will see what type of errors are coming. Yeah, there is error. Because you are storing higher data in lower data. Means I is my higher variable, B is my lower variable. So whenever you are storing from higher data to lower data, then it requires what? Explicit type conversion. It requires explicit type conversion. So that explicit type conversion, how to write? By writing typecasting. Here you should write within the bracket, because you are converting integer into byte. So write here byte. Automatically now the mistakes rectified. So once this program saved, now I will compile. Once you compile, that error should go. Yeah, now that error gone. Now if I execute Java followed by main, yes, how much? My integer value is 258, but how much in stored would be 2 only. Why? Because this is 4 byte data you have stored in single byte. So that means there is a coercion. That means the data something lost. Then how will you compute this value? How will you know? For that, there is a simple technique. Actually, byte capacity. Byte means 1 byte. In 1 byte, how much value you can store? Up to 256, isn't it? The maximum value is 256. So 258 modulus 256. How much? 258 modulus 256. So answer is 2. So that means to know that answer, you can apply the modulus operator. 258 modulus 256. Because in 1 byte, maximum I can store 256 only. So it will go in a cyclic way. So once it goes cyclic way, 256 gone, remaining how much? 2. So that's why answer is 2. That's why I got in B answer 2 only. Whereas here my I is as it is. How much? 258. So you cannot store 258. Okay. For example, instead of 258, I may go for only 58. In that case, what will happen? So 58 is the within the boundary, because in byte allows you to store how much? It will allow to store minus 128 to plus 127. That is the range of the byte variable. So I can store any value between this range. So my integer also 58. So my byte can support up to this. So there is no loss in that case. If at all it exceeds the boundary, then there is chance of loss. But here within the boundary, there is no loss. So I will get the correct answer. Same. Now, if I store 58, what should the answer? Now you see the answer. if a store, compile it. For every changes you have to compile it. Yeah, I got same 58, 58. Because this range is, the value is within the range. As long as you are within the range, then there is no loss. If at all the value is going beyond your range, then there is chance of loss of data. So that time you can apply the modulus operator and to calculate the value. Okay. So here, if the value is 58, so my answer is 58 only. So directly I will get 58. So here also 58. So this is the way it works. Similarly, I will give one more example how you can convert from one type to another type. This is an example of what? Explicit conversion. Example of explicit conversion. Similarly, implicit conversion. Plus main, open bracket, close bracket. Then you can write public static void main, and main requires what? The string argument array. String argument array. Of course, the name can be anything. You need not worry for that one. Open bracket, close bracket. Here, I will write here int I and char C is my variable, equal to A. Here what I wrote? One character variable. And here I am assigning I equal to C. I equal to C. Now, I want to print the value of I. System dot out dot println. What is the value of I? I equal to how much? Plus I. Okay. Similarly, I want to print the value of C also. C means as it is. What is the value of given C? Okay. Control C. So I will store the name same as main.java and convert the Java source code. And remember, please install Notepad C++ in your system and get this benefit. Yes, the file name already exists. This I will close. So now, file, save as main.java. Java source code, select it, save the file, automatically take the extension .java. Fine. Now you go to the name main.java, right click, go to the command prompt, open into containing folder, into CMD. Once you go here, then you can compile it, Java C, main.java. Now there is an error. What is that error? Semicolon means the square bracket missing. So you go to the program, here bracket missing. Okay, Control S, save the program, Java C, main.java. Okay, now Java followed by M. Now if I compile, what I'll get? I got I65. What is that value? That is my Unicode value or ASCII code value. For character variable C, I have stored A. The A's ASCII value or Unicode value is 65. That is stored automatically. So this program doesn't require any conversion. This comes under automatic conversion. Automatically it will take its value and store it. So in this case, you need not write explicit within bracket. Nothing to mention. So here my value of C, that is my actually A. A's ASCII value is how much? 65. So 65 will be stored. So remember, for every character there is a ASCII value or Unicode value. Actually in Java also Unicode. In C, C++ will say ASCII code. So in Java also say Unicode. So the Unicode value of A is 65. It goes up to Z. Z value is how much? 90. So 65 to 90, that is in uppercase. For lowercase, 97 to 122. This is for lowercase. This is for uppercase. For uppercase alphabet, the starting Unicode value is 65 up to 90. For lowercase, the starting Unicode value is 97, ending is 122. That means up to Z. Okay. So once you know this thing, similarly, for character 0, character digital 0, ASCII value is how much? 48. This go up to character 9 up to 57. 57. For example, here, a simple example I will say now. Assume instead of A, I will write here 9. What 9? Character 9. That character 9 I am stored in C. That value again I am assigning to I. In that case, what will happen? This is the character 0, this is character 9. So when I say character 9, automatically how much value will be stored in I? Its Unicode value, that is 57. So automatically 57 will be stored. 57 will be stored. Okay. So my answer of I will be 57. Now let us see how it works. So once you compile, because for every changes you compile. Now run. Yeah, I got how much? 57. But C is my character 9. Its corresponding Unicode value is stored. So this is the way you can do typecasting. This comes under your implicit typecasting. Okay. Means that value automatically stored. And I will give one more example. Plus float data. Public static void main string argument array. Okay. Open bracket, close bracket. I am declaring one float variable, float x equal 2.3. 2.3. Now I want to print system.out.println f. System.out.println f. Sorry, x I have to print. X. How much it print? Because I am storing x with 2.3 and printing that x. So what is the answer? You see now. The program name I will give as floatdata.java. Control C. Control S. And I will store as a Java source code. Select Java source code. Once you press J, it will come. You need not write .java also. Automatically the system will take. Then right click on this. Go to the containing folder. Once you go there, then you type Java C float data. You see the error. What error is coming? Because this program having some error. Yeah, there is error. Incompatible type. Possibly lost conversion from double to float. Because in Java, when you write 2.3, 2.3 means what? It is always double. But x is what variable? Float variable. So you are trying to store double data in float variable. That's why the system is giving error. So when you are going from higher to lower, it requires conversion, explicit conversion. So how to do explicit conversion? You can write within bracket float. This is explicit conversion. Control S. Now I have converted the data from double to float. After conversion, then again compile. Yeah, now there is no error. There is no error. Yeah, now I got 2.3. So this is the way you can rectify the mistakes. Most of the time, the student, they will do this mistake. So now onwards, you should not do this mistake. You can do this way, or there is another way of solving this problem also. For example, float y equal to 2.3 or 2.5, for example. Then here I am printing the system dot out dot println within bracket y equal to plus y. Now here also error, but here I do not want to go for conversion, but automatically I should write in such a way that it must come to float type. Now see what error is coming. If I execute, I will get the error. Yeah, there is error. So here I do not want to go for explicit conversion, but there is another way. Simply write f. In Java, if you write f at the end of the variable, automatically that data will convert into float type. So remember, when I write 2.5, what is always it is a double. Always it is a double. So to make it float, you can write f letter. Once you write f letter, automatically the data become float. So there are two ways to store the decimal data in a float variable. One is by explicit conversion or by writing f. Now, if you write, now that error will be gone. Now see, now there is no error. Now execute. Yeah, I got 2.5. Okay, so this is the way you can solve it. So you have seen how to do implicit conversion as well as how to do explicit conversion also. And remaining part will continue in the next session. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.